Welcome to Wireless Communications course. This is the first lecture of this course, and in this lecture I want to give an overview of wireless communications. I present this lecture by slides, and the slides are made based on the following two textbooks. The first one is the book of Andrea Goldsmith. The title is Wireless Communications. And the second book is Fundamentals of Wireless Communications by David TSC. The history of wireless communications, it goes back to pre-industrial age, when people used some signals to communicate, a kind of line of sight distances communications. They used torch signals, smoke signals, flares, the signal of flares, flashing mirrors, and semaphore flags. They can use these signals for two-way communications in both sides. Each transmitter could send these signals, and the other sides can be aware of that without any special means to detect or receive the signals. And later on, the telescopes were developed. The first reflecting telescope was developed in Netherlands in the early of 17th century. They used glass lenses, and it was used in terrestrial and astronomy applications. The second type of these telescopes were invented within a few decades of the first one. They used mirrors to collect and focus light, and these again were used for line of sight communications. After these two types of telescopes, the first type of telescopes based on radio communications was developed in 1930s, and the second type of modern telescopes based on infrared waves were developed in the 1960s. Of course, before these times, another communications means like telegraph and telephone were invented. In 1838, the telegraph was invented by Samuel Morse. Later on, about 40 years later, the telephone was invented by Graham Bell, a Scottish immigrant. Then one very breakthrough technology was born in the field of wireless communication, that was radio communications. In 1895, radio communication was born, and it was developed by the experiment by Italian scientist Marconi. Of course, before his practical invention, the radio waves itself were first identified by Hertz, Heinrich Hertz, the German physicist. That was in 1886. So after about 10 years, Marconi developed a practical system, a feasible system in reality by establishing a wireless link from the island of Wight in the UK to a tugboat 18 miles away. The radio systems can be categorized in two groups, analog and digital. The first generation was analog, and then by developing digital systems, the digital radio systems were developed, and the signals here are some kind of data or bits. Any analog signals can be digitized by digitization and converted to digital signals, so that the signals are carried by the digital systems, digital radio, using bits information. Then the next step in developing of digital radio systems are conducted by some research at the University of Hawaii by introducing packet radio. The packet radio is the system based on grouping of the bits. So the bits are grouped into a packet, and instead of sending data by bits, the information is sent by packet, a group of bits. The first packet radio network called AlohaNet. It was developed at the University of Hawaii in 1971. In that network, there was a computer, a central computer on Oahu Island, and the network that was created by computer science at 7 campuses over 4 islands were connected to that central computer. AlohaNet actually is a set of protocols for channel access and routing, and still these protocols are used in many networks, data networks. Another development in wireless communication was done by Department of Defense in the United States, a project called DARPA, Defense Advanced Research Projects Agency. This project aimed to develop network using packet radios for military use. In the 70s and 80s, this project was done, and the outcome was this project was wide areas wireless data services. These services were based on packet radio network, and the first network was introduced in the early 1990s. These services are like emails, file transfer, and web browsing, and the speed of that service was in order of 20 kilobit per second. And the second technology that came out from that project was Ethernet technology. In 1970s, this technology was developed, and it steered many companies away from radio-based networking, since the data transfer, the speed of data transfer was much higher than the radio based uh, data transfer. That was about 10 megabit per second. Then many companies use this technology for data communications. We have a term called local area network for the technology of Ethernet. The local area network is a network of computers which interconnects the computers within a limited area, such as a residence, university campus, schools, or in office buildings, so that the computers are connected wirelessly or by wire to each other. And there are a lot of type of topologies here to connect the computers. Here we have two kind of technology based on wireless or wired communication. That is Ethernet and Wi-Fi. Ethernet is a technology that uses wire to connect the computers. Wi-Fi is a technology that wirelessly connects the computers and the networks in the networks. The early experimental and commercial LAN technologies were developed in the 1970s. As I said, these experiments were done from that project developed and supported by Department of Defense of the United States. In parallel, one local area network based on using ring topology was developed at Cambridge University in the UK in 1974, and that was called Cambridge ring. Later on, at the same time, 1974, the Ethernet was further developed by a company called Xerox PARC in the United States. And then the protocol for Ethernet was developed by a corporation, Data Point Corporation, in 1976. The protocol called ARCnet. The initial local area network offered very poor performance in terms of data rates and coverage. They didn't have security, they didn't have standardization, and they were very expensive. For example, a wired Ethernet card was a few $100s, and the first network adapters was $1,400. Then during the development of networks, the wireless local area network was developed at University of Hawaii. It was developed by Professor Abramson from this university, and the world's first wireless LAN called AlohaNet, as I mentioned before, was developed in reality, physically developed in this university. As I said, it included 7 computers deployed over 4 islands to communicate with the central computer on the Oahu Island wirelessly. Since these links, these wireless communication links, consumes a bandwidth. They need a special range of spectrum, electromagnetic spectrum, and to avoid interference between these range of frequencies, a federal commissions in the United States called Federal Communications Commissions, or FCC, in 1985 authorized the public use of some frequency bands called ISM, Industrial, Scientific and Medical, for wireless LAN products. So any group, any individuals wants to have research in these areas, they don't need to obtain a license, an FCC license, to operate in this band. As I said, the telephone was invented in 1876, and about 20 years later, the radio communication, a real radio communication, was established and developed in 1895. So both technologies were there, and about 20 years later on, in 1915, the radio and telephony were converged. First, the wireless voice transmission, a real wireless voice transmission link, were established between New York and San Francisco, and the first public mobile telephone then was introduced in 25 cities across the US in 1946, about 30 years later, on the convergence of telephone and radio. Of course, the cellular telephone was there, kind of cellular one, but the concept of cellular one was developed later on, not that time. The systems had a central transmitter to cover an entire metropolitan area. But the insufficient or inefficient use of the radio spectrum severely led to limit the system capacity, because they didn't use the spectrum, the radio spectrum, efficiently, so they couldn't support many users. For example, in those networks, based on those concepts, the New York system, communication system, could only support 543 users. Then the cellular concept was developed. The first one, this concept was developed by AT&T Bell Lab during the 50s and 60s. However, there was a problem with the regulations of frequency, since the FCC had a delay to authorize the use of the frequencies, and the system, because of this delay, was developed later, by early 80s. The basic idea behind the cellular concept is this: the signal power is dissipated with distance. So the same frequency channel can be used at spatially separate locations. So for each frequency bands, each signal of a user will be dissipated at a distance. Then out of that distance, we can use that frequency again, because we don't have that signal, so that we can have the same frequency band for other users. So as a result, a cellular system splits an area into adjacent non-overlapping cells. Another concept for cellular systems is base stations. Base station is a centralized transmitter and receiver that communicates with the mobile units in each cell to control and call relay. Base stations are connected to a mobile telephone switching office, or MTSO. The MTSO has connection with the public switch telephone network to connect the mobile phones to the landline phones, the home phones. Another concept is handoff. Handoff is establishing the links when a mobile unit cross the cell boundaries, the handoff is established. It is typically handled by the mobile telephone switching office, as well as partly by the base stations or mobile units. As I said, the first cellular systems were developed by AT&T Bell Labs during the 50s and 60s. The first cellular system was analog, that was introduced in Chicago in 1983. As the system spectrally saturated by 1984, the FCC increased the cellular spectrum location from 40 MHz to 50 MHz. But still, it was not enough in terms of spectral efficiency. The spectrum was not used efficiently, so the researcher was thinking about digital cellular systems. So due to capacity limit and to get better performance, the development of digital systems became essential. The digital cellular systems, that was the second generation of cellular system, were introduced in late 1980s. In these systems, beside voice communication, they offered email, voicemail, and paging services. And a large demand for cellular cell phone led to an evolution of many technologies and standards. In the United States, there are 3 digital cellular phone standards, including Interim Standard 54 and 136, or IS54 and IS136, or Digital Advanced Mobile Phone Systems, which, in short, DAMS, and IS95 and IS2000, which are based on Code Division Multiple Access, or CDMA based standards, and Long-Term Evolution, or LTE. And of course, there are more standards in Europe and Japan, and interestingly, none of them are compatible. Another wireless systems called radio paging systems. A radio paging system is a wireless data network. It is in a wireless data network and the pagers send message over a relatively small area by a low power transmitter. Also, they allow coverage over very wide areas by simultaneously broadcasting at high power from multiple base stations or satellites. Another major component of wireless communications infrastructures is satellite communication systems. The satellite communication systems provide a broadcast service over wide areas all over the earth. These systems has the same working principle as cellular systems. Here, the satellites in the skies act like the base stations in the cellular systems. So the satellites are orbiting the Earth and they act like base stations. The satellite systems are characterized by the height of the satellite orbit. We have three kinds of satellite systems based on the orbit, the distance from the Earth to the satellite: low Earth orbit, medium Earth orbit, and geosynchronous orbit. The low Earth orbit is located at about 2,000 km altitude. The medium Earth orbit is located at about 9,000 km altitude, and the geostationary or geosynchronous orbit satellites are located at about 40,000 km altitude. The concept of geosynchronous satellites for using in communication first suggested by the science fiction writer Clarke in 1945. I want to say this concept that the synchronous satellites are the ones that the speed of the satellites are the same as the speed of Earth, rotating speed of Earth, so that at each time when you look at the satellites in the sky, we can see that satellite, so it's synchronized by the speed of the rotation of Earth. The first GEO or geosynchronous satellites was launched by Hughes and NASA in 1963. Of course, before that first launch satellites, there were two satellites were launched in the sky, but they were not geosynchronous. And NASA Bell Laboratories Echo 1 in 1906 and the Soviet Union Sputnik in 1957 were launched, but they were not geosynchronous. The most well-known GEO satellite system is called Inmarsat. Inmarsat is the name of this satellite. Today, it is a great interest in using lower orbits, LEO satellite, since these satellites can have communications with handheld devices in the Earth. With the global coverage, the LEOs provide voice, paging, and messaging services, but they are slow, and they offer low data rates service because they have constraints in power and bandwidth. The most common uses for satellite systems is TV broadcasting. The satellite TVs mostly the most common use for these are the most common uses for the satellite systems. The direct broadcast satellites operate in the 12 gigahertz frequency band, that is for TV, and the radio also has another service for satellite systems, and they provide digital radio, and the frequency bands for this application is 2.3 gigahertz.